This is Mr. Precella. Let's do a few more examples using the cut point method for solving these inequalities. Let's see. We're going to be drawing a number line and shading intervals. So I'm going to do this using what I call the cut point method. And to get started, you're going to find what we call the solution cut points, which is, okay, replace the inequality symbol with an equal sign and solve for x, or whatever the variable is, okay? So replace the inequality with an equal sign, solve for x. So here goes. This is this number 3 right here. I'm going to replace this with an equal sign. So I would have x times x minus 1 equals 12. Well, okay. Distribute the x. So we'd have x squared minus x. This is a quadratic equation because of the x squared. So I'll move the 12 over by subtracting 12 from both sides. And solve this thing by factoring. Let's see. To solve it by factoring, let's see. This one factors pretty easily, doesn't it? X and x. For the last two spots, we need to put numbers that multiply together to give 12. So 1 times 12, 2 times 6, or 3 times 4. 3 and 4. Second sign is minus, so 1 plus and 1 minus. To get a negative 1x by the middle, it would need to be like that. A plus 3 and a minus 4. Now set each one of these to 0. When you set x plus 3 to 0, move that 3 over, you get x equal negative 3. When you set the x minus 4 to 0, you get x equal positive 4. So we've just found the solution cut points, negative 3 and positive 4. When we plot them on a number line, we're going to use a closed circle, because if you actually plug a 4 in here, or a negative 3, you're going to get 12. 12 less than or equal to 12 is true. So we're going to plot these with a closed circle. So I draw a number line. When you draw that number line, make sure you're numbering them or labeling them in numerical order. Negative 3 is to the left of 4. Put a closed circle. Now, if there are no repeated factors, when you have it factored, if you don't wind up with the same factor appearing more than once, like x plus 3 times x plus 3, then it's going to alternate. So I'm just going to test one of them. And usually I test 0. 0 is right here between a negative and a positive. When I test, I'm testing it by plugging it into the original problem. If I put a 0 in place of x right here, we'd have 0 times 0 minus 1 is less than or equal to 12. Well, 0 minus 1 is negative 1 times 0. 0 times anything is 0. So we have 0 is less than or equal to 12. Well, is that true or false? Well, it's sure not equal, but it is less than. That's true. So the other ones, the ones beside it, would be false. And what are your answers? Your solution's going to be the false, the true interval, not the falses. The ones you've shaded. You've got right bracket, negative 3, comma, 4, bracket. Notice we didn't have to find any denominator cut points here because there were no denominators. What about number 4? 4. Ooh, let's see. How's that going to work out? Number 4. Let me move this out. You know what? Maybe I have enough room. I might not need more room to do this one. On this one, we're going to have to find the solution cut points. You do that by setting equals. Now, what about a denominator cut point? Are there any fractions? Are we going to have to find denominator cut points? Yes, because there's that denominator. So we're going to have to say denominator can't be 0. So here it goes. I start off finding the solution cut point, and I think I'm going to do it in purple right here. Solution cut point. You write the original problem and put an equals instead of that inequality symbol. So we have negative 4 over x minus 4 equals negative 1. I'm going to go ahead and write that as negative 1 over 1 because I'm about to cross multiply. Okay? When I do the cross multiplying, what would I have? Negative 4 times 1. Negative 4 equals, multiplying both of these by negative 1, we have negative x and a plus 4. Now we need to solve this thing for x. And when I say that, I mean for positive x, so we don't need that negative there. Here's what I'm going to do. I'm going to add x to both sides, which will move the x over to the left. And also I'm going to add 4 to both sides to move this 4 over here. So what are we getting as a solution cut point? When you move this over, we get x equals, moving that negative 4, we're adding 4. 4 plus 4, 8. Now let's look right now and decide between open and closed circle. How do you decide that? You look at the original inequality, the problem in you look at the inequality in the original problem. There's not an equal sign, so it's going to be an open circle when we plot the 8 on the number line. Why an open circle? Well, if you actually plug in 8, you're going to get negative 1. Negative 1 greater than negative 1 is not true. Now, how about in blue, I'm going to find the denominator cut point. Denominator can't be 0. So x minus 4 can't be 0. X cannot be positive 4. If you try to plug in negative 4 over 4 minus 4, your calculator is going to give you an error because you'd have negative 4 over 0. You don't want that to be, this 4 to be part of your solution. So always an open circle. Now I'm going to draw a number line. And label those 2 cut points, 8 and 4. Make sure that you're putting them in numerical order. 8 would be the bigger one. And they both have open circles. There were no repeated factors anywhere there. It was all just linear factors and no so let's see. Where does 0 lie? That's the thing I'm going to test. 0 would be right here between a negative and a positive. So I'm testing 0 by plugging into the original problem. You have negative 4 over 0 minus 4 is greater than negative 1. Well, negative 4 over negative 4 would be a positive 1. 1 is greater than negative 1. Ooh, there goes the light sensor. That's true. So true, false, true. So you write your answer in interval notation now. What would it be? Well, here's the thing you're going to have to type in. I'll write it right here in this color blue. Parentheses, negative infinity, comma, 4, parentheses, union, parentheses, 8, comma, infinity. You know, tell my 8s from my infinity symbols. Okay. It's a nice way of solving inequalities. Any questions on that? That's a very nice example. Here's an example that I've just made up that I want to do. We've got some trigonometry there. I need to see this. Suppose we want to solve this. Here's an inequality that we're going to solve. X squared minus 4x plus 1 is greater than negative 3. Well, we'll start off solving as if there's an equal sign. I'm finding the solution cut points. X squared minus 4x plus 1 equals negative 3. I would need to move that 3 over to get x squared minus 4x plus 4 equals 0. Now I'll try to factor it. X and x. 1 times 4, 2 times 2. Well, 2 times 2, second sign is plus, so 2 of the first. We want these 2's to multiply together to give a positive 4, but add together to give a negative 4. And when we set these to 0, we're just going to get one cut point. X equals 2. This is what I mean by repeated factors. Now there's no denominator cut point, is there? So if I draw a number line, negative infinity, positive infinity, and put a 2 there, what would I need to put on this 2? Open or close circle. This was a solution cut point, so you look up here. There's not an equal sign, so it's going to be an open circle. If you actually plugged in a 2, 4 minus 8 plus 1, you would have negative 3. Negative 3 greater than negative 3, that's false. Open circle. The reason I just made up this one to do is to show you with the repeated factors, it might not just alternate. You better test both intervals. So like right here, what number do I want to test? Well, a number between negative infinity and 2, well, one number that's always between a negative and a positive is 0. Then over here, a number between 2 and infinity, I think I'll test 3. So plug in a 0 in to the original problem. That's going to be pretty easy. 0 squared is 0. 4 times 0 is 0. Plus 1 is greater than negative 3. So we just have 1 is greater than negative 3. Would that be true? So shade here. Now don't assume this one's false. I deliberately made up one to show y'all. Here if we plug a 3 in, we'd have 9 minus 4 times 3 is 12 plus 1 is greater than negative 3. The 9 plus 1 is 10 minus 12. That's a negative 2. Is negative 2 bigger than negative 3? Yes. Right? You'd rather have negative $2 in your checking bank account than negative 3. Okay? Negative 2 is bigger than negative 3. You see, here's another one of the truths. So it's possible that it won't just always alternate. And you can spot the ones that might not by saying, okay, are there any repeated factors like that? If what you have is just linear and you don't wind up with any quadratic equation and having to factor anything, then it's going to alternate. Like this number 4 did. Okay? There was no time you had a quadratic equation and had to factor anything. Now, well, how would I write the solution here? Well, it'd be negative infinity to 2, close parentheses, union, parentheses, 2, comma, infinity. Okay? This is a nice little way of solving inequalities. We've done 5, 6 I've done on a separate video. It'll be included there. Let's do either 7 or 8. I think I'll do 8. I'm going to do number 8. Almost out of time, but I think I have time to do that. So I'm doing problem number 8. Notice on this one, all you got to do is just multiple choice, pick the graph. 7 and 8, both of those. But you know something? I'm going to hide those answer choices. So on this one, are we going to have any denominator cut points? Yeah. My habit is to always find the solution cut point first, but you don't have to. Write it as W over 4W minus 5 equals negative 3. I'm going to say over 1. And I'm going to do the little cross multiply. 1 times W is just 1W. Negative 3 times 4W minus 5 is a negative 12W plus 15. I'll move the W's all to one side. I can do that by adding 12W to both sides. 1W plus 12W, that's a 13W, equals 15. And then divide both sides by 13. So the 15 over 13, that's our solution cut point. Look at this symbol, and there's going to be an open circle because there's not an equal sign on it. And I'm following these steps for finding the solution cut points. Replace the inequality with equal, solve that equation, use an open circle if there's a less than or a greater than in the original problem, use a closed if there's an equal, and we've discussed why that is already. Now let's find the denominator cut point. Okay. How do I know there's a denominator cut point? Well, there's a denominator. So let's find the denominator cut point. The denominator cannot be 0. So move the 5 and divide by 4. So W can't be 5 over 4. Because if it were, we'd have a 0 down there in the bottom. Always use an open circle for the denominator cut points. And then label these numbers on a number line. I guess if you looked and saw real fast, the 15 over 13 is going to be on the right, the 5 over, on the left, the 5 over 4 is going to be on the right, but if that hadn't been drawn out for you, well, maybe what you want to do is punch in to figure out which one of these is to the left. Maybe punch these numbers into a calculator, like 5 over 4, or maybe you already need a calculator for that. That would be 1.25. What about 15 over 13? If you punch in 15 divided by 13, 15 divided by 13, 1.15. Versus 5 divided by 4, which is 1.25. So the 1.15 is smaller than 1.25. That's why the 15 over 13 is to the left of the 5 over 4. It just dawned on me, this orange is hard to see, isn't it? Now both of these should have open circles. And there was no place that I factored and run the risk of getting or got any repeated factors. So it's going to alternate. So I'm going to test this interval. Why? Because that's the interval that has 0 in it. I'm going to test 0. We'd have a 0 on top. I'm plugging into the original problem. And then 4 times 0 minus 5 is a negative 5. Is less than negative 3. 0 divided by negative 5 is 0. Is 0 smaller than negative 3? No, I don't think so, right? 0 is bigger. You'd rather have $0 in your bank account than negative $3, okay? So this is false, true, false. So which one of these graphs am I going to choose? It's going to be C, isn't it? Okay. C. It's called an open interval. If you'd written the answer in interval notation, there'd be 2 parentheses, and it's called an open interval because they have no open circles on each of those. Okay? Well, maybe that's a good way to remember. So, I guess I'm done discussing solving inequalities with cut points. Until the next time, we're going to see how we can use these cut points to solve some absolute value inequalities. Somewhere along the way, you've already solved absolute value equations, but we're going to solve some absolute value inequalities using these cut points. And wow, it's really nice using this method. So I'm going to be doing it different from how the View an Example does the next assignment, discussing solving absolute value inequalities with cut points. Okay? So I will, it's time to go. We're out of time. Okay, bye-bye.